morning. My name is Beth Capellas, and I am the marketing manager here at Triangle Microworks. I'd like to welcome everyone to our latest webinar, Reduce Travel and Increase Productivity with SCADA Simulation Tools. We are expecting a very large crowd this morning, so we're going to give it another minute or two to let everyone join. So just sit tight and we will begin momentarily. Okay, we still have a lot of people joining, but I would like to just start by going over a couple of housekeeping items while everyone continues to join. The webinar is scheduled to be 1 hour long. However, we typically get a very large amount of questions, so we are happy to stay on longer to answer as many questions as possible. With that said, I'd like to encourage questions throughout the webinar. Since the audience is on mute, please submit your questions using the webinar menu under the section titled Questions. You can start asking questions as soon as you have them. Don't feel like you have to wait until the end. We will begin trying to answer questions online. I do have a couple of engineers that are monitoring the questions coming in, and hopefully we'll be able to respond online as soon as possible. We will also stop a couple of times throughout the webinar to read and answer questions. And of course, there will be some time at the end that we will dedicate specifically to questions and answers. And again, we'll stay on past the hour time frame to answer all the questions that come in. So with that said, I'd like to introduce our speaker, Matt Green. Matt is a senior applications engineer and has been with Triangle for over 5 years. He is also one of the main testers and an expert on Distributed Test Manager. This is the tool that you'll be seeing here today. So with that, I'd like to go ahead and hand it over to Matt.
Hello, everyone. As Beth said, my name is Matt Green, and I'm a senior applications engineer here at Triangle Microworks. I figured we'd start by talking a little bit about Triangle Microworks. We were established in 1994 in Raleigh, North Carolina, and we have been working in the protocol communication fields ever since. We have customers all around the world, including equipment manufacturers, system integrators, and electrical utilities. So we have a wide variety of products that we sell, including source code libraries for DMP3, 61850, 6870, 101, 102, 103, and 104, TASI2 or ICCP, and Modbus. You may also have heard about us about our SCADA data gateway, which is our gateway application for protocol data mapping and concentrating. And then we also sell a collection of testing tools like the 61850, Test Suite Pro, DTM, Test Harness, and Iron. As you all know, COVID-19 has really changed the landscape of how we're all doing business. These changes include forcing us to distance ourselves from our normal work environments, shipment cancellations, or delays from our hardware vendors, and restrictions on our ability to travel. As a result, we've had to adapt new ways to get our work done without letting our productivity suffer. This is especially important since we are a critical industry that everyone relies on. So today we're going to be presenting our tool DTM to help maintain this productivity through this and all future challenges. DTM is a system-level simulation tool used for simulating devices and running tests on entire systems of devices. One of the largest concerns in our industry is that our deadlines will be missed and projects will be delayed due to unforeseen circumstances, such as we are experiencing now. Whether this is a shipment delay from our hardware vendors or limited time with the hardware that we do have, not being able to use the hardware that you need is a big problem. And this is where DTM comes in. DTM can be used to simulate these missing pieces of equipment and allow your project to progress. Another large concern in the industry is our restrictions on travel. Many of our customers work from the design phase of a system through its deployment and maintenance. This requires them to travel to their installed system and work through a series of test cases. DTM can be used to simulate this system and have the test cases run across the simulated system. This will allow you to discover problems earlier on in the process and help reduce risks during your deployment. This will also help your team become more familiar with these tests, allowing them to return home quicker when they are required to travel. So let's take a look at DTM. So DTM stands for Distributed Test Manager. It allows for large networks of protocol devices to be simulated. This simulation can be done on one Windows machine or distributed across multiple computers to spread out the load and generate more realistic network traffic. I have already preloaded one of our finished workspace to show an example of what a simulated system would look like once it's configured. But after we show that off, we'll take a look at how to create and configure a workspace like this. On the left-hand side here, you'll see the workspace section. This is where everything that you create in DTM will be housed. This includes all of your protocols, all of your protocol devices, any of your displays, your test managers, and any of your scripts. DTM can simulate both the controlling and controlled devices. This includes clients and masters, slaves, outstations, and servers, and it supports DNP3, ICCP/TASI2, IEC 6870, 101, and 104, 61850, and Modbus. In the middle here, you'll see a single line diagram of the network that we are simulating in DTM. This is all placed on an onsite display, which could also be used to simulate an HMI or a SCADA display, a faceplate to an actual device, and actually has multiple other uses as well. The IEDs simulated in DTM are monitoring the electrical equipment in this diagram, and their databases will reflect the value that are determined by the state changes of these devices. We've also added a few buttons and checkboxes here to allow us to trigger events inside the system. And then on the far right-hand side here, you will see our test manager. This allows for manual and automated testing of your network. Each row here is a single test, and the results can be seen in the results column. The tests are defined inside of a JavaScript that you can see once you click the Edit Test Script button. The test being configured here is really determined on what type of tests that you're doing and what your devices under test are. So I'm going to jump back to the PowerPoint now for a bit to explain a few test cases that DTM was designed for. This diagram illustrates the typical communication paths in a generic substation containing IEDs, potential PLCs, an internal HMI, a data concentrator, and your SCADA system. We will use this diagram to illustrate how DTM can automatically test each of these devices by simulating the other devices around it. The color of the box determines whether the device is simulated in DTM or the device is under test. A gray box indicates that the device is not required for this test scenario. In this test, we are simulating the inputs to the HMI and monitoring the responses from the HMI to make sure it's displaying the data properly. So you can have a user simulate the data changes down here on your simulated devices and then check for the response at the HMI and report back to DTM for a pass or fail. Alternatively, you could feed a sequence of events log from your HMI back into DTM, and then DTM can automatically verify that the HMI was displaying the proper data. We can also test a data concentrator or a gateway. You can do this by simulating the same IEDs and PLCs in the downstream data, but also simulating the SCADA upstream that the data concentrator reports to. In this situation, since DTM is able to simulate both sides of the data concentrator, we're able to automatically change data downstream and verify the proper data is changed upstream. This allows us to do an automated test of the entire data concentrator. So we actually have an example of this in DTM. So let's jump back over there and take a look at that. So let's take a little bit closer look at this workspace section I was talking about before. So in this workspace that I've created, we are simulating the substation, or IEDs in the network, the HMI and data concentrator, and then the SCADA. These are all folders, and the devices simulated are inside. So for the data concentrator test, we would go to the HMI folder, right-click, manage, disable devices. That would disable all of the SCADA, all of the data concentrator inside of the HMI here, allowing us to plug in, say, our SCADA data gateway and run the automated tests on. We'll still be simulating the downstream IEDs and the upstream SCADA. So we'll look at this status test, which is what our automated gateway test is, and that would bring up this test manager here. And what you'll see is a variety of tests here that will go through and test all the inputs to the data concentrator and match that to the outputs. So what will happen is if I click this test, it'll run through and change the value on the downstream device. Alternatively, you can go through and run these extra tests. So what's happening, if you look here at the description, is that the source of the data is this CSWI general. We change that automatically downstream. The value is then passed up to our SCADA data gateway, which is then mapped to a MD&P device. And then that is being pushed up to our SCADA system at the top. So once we have both forms of data, we can compare them together and see that the results passed and took about 100 milliseconds. And of course, you can go through and select multiple tests, run all the selected runs, run all of your tests, and have it all done automatically. After you have your test results that you're happy with, you can go down to Export Results and save that off as a text file, HTML, CSV, and XML. This will allow you to see test results and group all of your individual tests together. So let's look at a few other examples of testing. This is our SCADA point test. So this is very similar to the data concentrator test, but now that we've verified that the data concentrator is working properly, we've now added in the physical SCADA system. This way, we can test that the SCADA is displaying what is necessary being passed up from the data concentrator. An alternative test for this would be if we just simulated the data concentrator in DTM, everything below would no longer be necessary to simulate in DTM, as we just really care about the outputs from the data concentrator up to the SCADA. In this scenario is very similar to what we were doing with the data concentrator. We're simulating the source of all the PLC's inputs and the recipients of the PLC's outputs. This way that we can determine that the PLC is behaving properly in the system. In this testing scenario, we're simulating everything around a single specific IED. This will allow us to check that everything from basic protocol communication to making sure device behaviors are performing properly for all inputs in the system. So now that you have gone through and tested each of your devices, we're able to build up a full network. What you can do is you can go in and disable simulated devices one by one and then replace them with physical devices. During this process, you can monitor the health of your network and run any of your automated or manual tests as you swap out devices. This should allow you to pinpoint which devices may not be behaving properly with other real devices. And then this is the last example I'll be showing off today. In this situation, we're simulating the IEDs and the PLCs in the network. Everything external facing is now physical, which allows people to run through practice scenarios on backup systems without any risk of affecting your actual IEDs. This provides a perfect environment for operator training and for building user confidence when running actual tests in a network. So let's go back to DTM now. and I'm going to show off a IED test or a system-wide test. So that would be stored here under this substation testing, which is the test manager I have in this separate tab. In this situation, we have defined 6 different tests. We've got a recloser situation, differential protection, zone 1, zone 2 distance protection, a retrip, and a breaker failure. So these are going to be more along behavioral testing rather than just a simple point verification. So I'm going to go ahead and reset our simulation, and everything should be set back in the normal situation. So if I run this recloser test here, what we should see is that the recloser here has passed. And what that means is that if you watch, I'll run the test again, you'll see over here that this breaker will open because a fault was, say, detected, and then it will close as the recloser tells it to close back. So keep your eye on this breaker right here. It'll open, and then it'll close. And now we've gone through and monitored all of the signals in the system and verified that it was received. So to see something a little more dramatic, we could take a look at the breaker failure event. So the breaker failure is basically going to tell this breaker to open because there's a fault, but the breaker refuses to open. It's going to then cause all of the other breakers in the system to open up to prevent electrical flow. And as you'll see here, now this breaker is then opened along with these, and power has been cut off to the transformers below. This would be an example of an IED IO point test or a full system test as you swap in the physical devices. So let's take a look at the script. I'm not going to go into too much detail with this script as I don't want to bore you guys, but I can give you a basic overview of how it works. You, at the very start, define what your tests are, the name of the test and a brief description of what they are. Then you actually can go through and set up the specific tests. So this is the recloser test. What you do at the very beginning is set up the initial conditions, and then you will wait for the specific signals you expect to see in the system if everything is proper. At the very end, if you receive all the signals that you're interested in, you then return with a successful test and a brief description of how long it took. That's what we did, for example. But if something goes wrong, you can return a value of exactly what did go wrong to give your technicians the ability to troubleshoot more down as to what the problem was. So at this point, we're going to take our first break to answer some questions. So I'll hand it back over to Beth.
Okay, we do have a couple of questions that have come in. We've been answering several online as well. So let me go over to how can you use multiple computers with DTM?
So yeah, that is something I alluded to earlier on. If you look over here in the network tab, what you'll see is I have my DTM network and only mgreen PC. That's just the machine I'm working on right now. But let's say I had a virtual machine or a laptop or something else. I can set that laptop or virtual machine up as what we call a DTM slave. And that machine can hook up directly to my mgreen PC, and only one of those machines need to be licensed. That way, you can simulate devices not only on your master machine, my mgreen PC, but I could also delegate some of the workload out to, say, mgreen VM.
Okay. Another question, if you are testing SCADA, can you simulate multiple sources of data, ICCP, DMP, etc., simultaneously? And there's a second part. Can you create a script with different events in the simulated data?
Yes, absolutely. So if you are testing your SCADA system, you can mix and match all these protocols beneath it. So right in this example, we have a upstream, say, MDNP device. That's what our SCADA is, and that's going through a data concentrator. But of course, in your substation or multiple substations, you could have a variety of different protocols. As for scripting, yes, you can set up all sorts of events regardless of protocol to set that up. But later in the presentation, I'll show you different ways that you can set up the initial conditions, including scripting, but there are also a few other ways you could do that as well. Specifically, I'm thinking like a CSV file where you go through and you set up the initial conditions for all your different devices at once, and you could step through different states.
Okay, we've got another one here. As far as the substation testing setup, is there a library of predefined tests available for typical tests like those that are shown, or is there in-depth programming knowledge required?
So when it comes to setting up these tests, it really depends on what your specific use case is. One thing that we've learned is that for every customer we work with, their situation is similar, but not exactly identical to exactly what we've done before. So we generally will help you build up these tests if you need. As I kind of showed off earlier, it's not an extensive programming language that you have to spend months and months learning. It's just JavaScript. All of the support online that you can learn JavaScript with will be built straight into this. And there are a few hooks that we put directly into DTM, like getting points and setting values and things like that. But those are all pretty straightforward as well. So you don't have to have 10 years of programming experience to set up these type of tests. And if you purchase DTM, that comes with 1 year of maintenance, and we're happy to help you get off on the right foot, learn what you need to learn, and make sure that your time with DTM is successful.
Okay, and we'll take one more and then I think get back into the presentation. Can I use DTM to run test automation of IEC 62050 servers and clients?
Oh yeah, absolutely. So all sorts of, so the first thing is you'd obviously have to add your devices, which we'll be going over as later on in the presentation. But yes, it covers servers and clients for 6150, Goose, sampled values. Everything you'd expect in 6150 is built right into DTM. After you're simulating all of your devices, that's when you can come through and you do your automated testing, whether that's through the test manager or CSV playback or anything along those type of lines. But yes, absolutely.
And what I would say is keep the questions coming. We are continuing to answer them online as Matt continues on with the presentation, and we will stop again in a little bit for more questions and answers. But go ahead, Matt, if you want to continue on.
Sure. So I've showed you the final workspace that we have set up for our substation testing. Of course, you can run any of the scenarios that we've already talked about in the PowerPoint in this by just going in and disabling the device under test that we would be testing, replacing that with a physical device and running your test that way. I've showed off the data concentrated testing and the IED testing and showed how this workspace works. Now, when you get DTM, you'll have this workspace built into your sample workspaces, but you're probably going to want to be able to create something more specific for your use case. So we're going to take a step back now. I'm going to close this workspace out, and then we're going to start from scratch. So if you need to, you could always come here, do a file save workspace. That way you could load it later, but I am just going to close it and start from scratch. So when you install DTM and you run it for the first time, this is what you're going to see. An empty workspace here. You're going to see your getting started page, which essentially will allow you to load our sample workspaces. There's instructional videos, demonstrations, all sorts of things that you can click on here. And then you'll have your DTM network. So let's start with just the basic, how do you create a device? Well, the first thing I would say is you probably want to go over to your workspace and add some folders to keep things organized. So you could right click, manage, add, and then put a folder in. And I'll name this DNP Masters. Then the next thing that I'm going to do is I'm going to add a Outstations folder the exact same way. I'm going to right click, manage, add, folder, and DNP Outstation. So essentially, these are not mandatory. You do not need to do them, but when you have large sections of devices, you're simulating 20, 30, 40 of these things, it can get out of hand pretty quickly. So if I wanted to say create now an outstation, instead of doing it at the workspace level, I can do it from the outstation. So I can right click here instead, manage, add, DNP, outstation. And this is going to bring up our configuration wizard. Instead of going through and doing each individual configuration at a time, we've put them all in a series of tabs. the very first tab here is the device tab. And that's just really the global information. That is, where is my device going to be simulated? Again, to talk about the previous question that was asked, this is where you would determine whether it's running on your master machine or your slave machine, so my PC or my VM. So if you click this, you'll get a drop down of all the machines in your DTM network. Currently, all I have is mgreen PC, so that's what I'm going to choose. Then you've got a name of the device. By default, we just put in SDNP, but you can go in here and change this to whatever device you're simulating. The second tab is the channel tab. This is where you can come in and basically outline the behavior of this. By default, since you added a DNP outstation, we've set up slave and TCP and server. You could do serial, you could do UDP, you can change all these configurations, but the majority of the time when you create a slave DNP, this is what the user would like to see. We've also set it up so by default, the local address is 0.0.0 and the remote address is star. Essentially, this outstation is saying, if there's any master out there that knows where I am and wants to talk to me, let him talk to me. But you might want to be more specific than that. So you can come in here and do a drop down and select any of the IP addresses associated with your computer. You can also come in here if you wanted to and say type in a different IP address that's going to be more realistic to your system, and then click assign IP address. This will allow you to actually assign this IP address to your network adapter. And then after your workspace is closed, it will be taken off of your network adapter. So that way you don't just have a bunch of floating IP addresses around. But be careful, this is more than just a simulation. If you put an IP address that your coworker next to you has, there will be IP conflicts. So for the sake of this, I'm just going to select the default IP address that I have and put that as the remote address as well. For DNP3, the port number is 20,000, but because this is a testing tool and you may not have a whole laundry list of IP addresses assigned to your network card, we do allow you to increase, decrease, or set the port number to whatever you would like. The next tab is the sessions tab. And this is going to be where kind of the protocol specific configuration options are. So the ones that are most likely interacted with, we've put on this tab here. This includes for DNP link layer addressing, so your source and destination, whether you want to send unsolicited messages and secure authentication. That being said, if there's something that you need to simulate your specific device and it's not in the 3 previous tabs we've been talking about, there is an advanced tab. And this is where you're going to find everything, all the nuts and bolts of what you need to configure your device. Any sort of frame sizes, network type, link retries, anything like that's going to be buried in here. If there's anything that you need to simulate DNP3, it should be in here. If it isn't, send us a message and we can definitely get it in here. So let's take one step back to the database, and this is what a lot of your device configuration will be related on. And what that means is that this is going to be all of the points that your devices are monitoring. So by default, we throw in basically 40 of each type. It gives you something to play around with. It gives you something to learn with. That way you can go in and figure out how the binary inputs work, the double bits, the analogs, anything along those lines. But if you're creating a specific device, you can always go in, reset your database, and then add them back individually. Say you need 3 binary inputs, and you need 5 analog inputs. Now I've gone ahead and created this database with the values that I specifically need. And if you're going to create multiple of these similar databases, you can export the database to a CSV file, and then if you need to create this device again later, import it from that CSV file. You can also, if you have a CSV file already pre-set up with what the database is going to look like, you can either immediately import it from your design team, or potentially write up a small script or something that will translate it in a way that will be easily imported. That way you don't have to go through this manual process. So I'm going to put this back to our default database. And at this point, I have my device configured, the channel configured, the protocol specific configuration options done, and the database set up. If I hit OK, it would go ahead and create my DNP outstation. But the last tab here is the multiple devices tab. Once you go to this, you'll see a radio button, and when you click that, it'll gray out the previous tabs. And essentially why it does that is it's taking all the configuration options you did for this one specific device, and it's throwing them right here in this table. And it's saying you want to create multiple devices, you want to create it with the same configuration that you've done in the previous tabs. So now I can increase or decrease these devices as I need to. Now, we do need to keep these devices unique so they won't all run over each other on your configuration options. So we've done two things. We've changed the device name, that way you have unique names, and we've increased the port number. But you can still come in here and click on any of these configuration options and get a quick kind of update for that field. So if you did have, say, 3 different IP addresses, you could change them to your 3 unique IP addresses, change the ports all back to 20,000, and you're good to go. So I'll hit OK. And what you'll see is the devices are now thrown into this workspace. And you'll see that they have these X's over them. That means they're not fully started up. But now the X is gone, they have fully started up. One more thing I wanted to mention is that you'll see that these orange kind of network indicators are next to each of the devices. And what that means is that the device is up and ready to connect to something, but it has not connected to anything yet. So let's go through that same process and create the masters. So right click, manage, add DNP masters. And what you'll notice is this is the exact same thing. The S is now an M since we're creating a master. The same thing about choosing what PC you want to run it on. You've still got your IP addresses here that you can set. And create that just so they match. You've got your session information. One thing that will be different is the database, because by default, we're going to go ahead and have our masters go out and talk to our outstations to figure out what their database is, but you could add them here as well. And advanced is still here for specific master and DNP configurations. And then we still got the same multiple. So it's exactly the same. So if I click create masters, go up to 3, you'll see this is all incremented in the same way. If I hit OK, you'll see that the masters have now been generated for the workspace, and all the connection indicators have turned green. That means that not only is your outstation out there, but it is also communicating directly with the master. And this would be exactly the same process if, say, your device under test was your outstations. Well, you could just plug your outstations into a router or switch that eventually gets led to your computer. You could just simulate the masters in DTM. You would see your masters go green because they are connected to your outstations, and you'd be ready to run your tests. So that's how you do DNP3. This process is almost identical for 101, 104, and Modbus. That leaves ICCP and 61850 out. So let's talk about how you can make 61850 devices. So I'm going to right click, I'm going to add another folder, and I'm going to call this 61850 servers. Same process, right click, manage, add, right click, manage, add 61850 servers. And what you'll see is there's far less tabs this time. We've still got our friendly advanced tab with all of the specific 61850 configurations, but because 61850 is built up around a SCL file where all the configuration is already done, we've allowed for you just to import that file and it will automatically configure the device as needed. So you just select your SCL file, and then you go and import the configuration. And then let me go to the file. And then you just grab your SCD file. From here, I just hit OK. And what it's going to do is it's going to fill in the information here. And since this is an SCD file, it's the entire system of your 61850 devices. Underneath IED to load, you'll get a little drop down, and you can select all of the IEDs inside of that. So I'll select line 1 Bay controller. Here's where you can select your Goose adapter if you're using Goose. Sampled values is in the advanced tab, just because we wanted to make sure if you're doing sampled values and bogging down your system, you didn't just install DTM and you put it on your corporate network, and then there's a bunch of sampled values being shot around and delaying your network. And so we've made it a little bit more difficult to get the sample values, but it is right there in the advanced tab as well, just to make sure you know what you're doing when you enable it. So if I just hit OK now, what you'll see is line 1 Bay controller has been created inside of a folder. Now, if you wanted to go and create every single device inside of that SCD file, going through and doing this process over and over could be a little cumbersome. So we do have file import substation, and that'll bring up the same type of window we saw before. If you don't have your SCD file selected, you could go and import it like I just showed you. But since I've already created one device out of this file and imported it into the workspace, it already knows about it. So I can click here, hit OK. And this will bring up our import substation window. And what this will allow us to do is quickly import all the devices inside of the SCD file. This import substation can be run in 3 different modes. The first mode is SCL file restrict. So you got the file from your engineers, they say it's in tip-top perfection state, and you just need to test exactly what's in the file. So you're not going to have the ability to change IP addresses and port numbers and subnet masks, anything along those type of lines. The only option you can change in here is the hosts. And that's because that is a DTM specific requirement. What machine is it running on? So you could click the host and then do a shift click to highlight everything, go down to the multi-editor, and then select my machine as where it's going to be and apply that. Now, if I went ahead and say clicked import all, it would take all of the importable devices and throw them into my workspace. So what are the other modes that we can run in? There's the user-defined mode, and essentially what that is allowing you to define whatever you want. You can change the IP addresses, you can change the port numbers. Everything is up to your configuration, allowing you to not have IP conflicts with other people in the network or things like that. There's also loopback addressing, and when you do loopback addressing, it puts an IP address that you already have on your computer on all of the devices. That way you can very quickly click this button, click import all, and be done with it. So when you're importing these devices, you can look at the importable column here and see exactly what is able to be imported. And you'll see everything says yes, except for this one right here. And that's line 1 BC, because I've already brought that device over from the previous configuration. So you can come here and say, multi-select the ones that you're interested and drag those over. And that'll go ahead and generate those devices. Or of course, you can just click import all and get everything. And now I have 61850 and DNP in the same workspace. It allows you to mix and match these protocols to build up a more realistic system, or allows you to test a more complex device such as an HMI or a data concentrator. To see how you can automatically test HMIs or data concentrators, feel free to check out our previous webinar, and the link to that will be provided at like a follow-up email. So now we've got our devices simulated. What we want to do now is create a single line diagram. So you right click on the workspace or anywhere in the workspace and do Insight, which is where our displays are stored, and do add display. I'll name this single line. And what that will do is it'll go right here in this middle section and bring it up in an edit mode. So what are some things that we're going to need? Well, we're probably going to need a bus bar. So I'll pull that over. This is our palette where all of our visual elements are. Probably going to want a breaker. Switch both sides of the breaker. Probably want a current meter, and then some load down here at the bottom. So I have now just visually created a very, very simple one line or a bay or something like that, right? So I can come in here and then connect everything up. But what you'll notice is that these icons are not actually connected to anything in the simulation. So we're going to want to do that next. I did the wrong thing. So how we can do that is we can display the databases that I was configuring before. So I'll come over here to this outstation and I will do a right click, show database. And this will bring up all of the databases that we configured. You'll see it's just the 40 of each. So I will drag this over, put it right next to our single line, readjust this so we can see it a little better. Now, what each of these icons have is if you right click on them, you can do a property. So if you do show properties, you'll see over where the palette was now, we now have a property editor. You can use any of the values inside of your outstation to reflect its state in these properties. The ones that I'm going to be working with today are the state, which is essentially if it's open or closed, and the right tag name, meaning if the state changes, it gets written back to this point. So you can just take the point you're interested in and drag it directly over. And what you'll see now is if I do show points again, show properties, is that both the state and the right tag name have changed to reflect back to this T1 P0 of that DNP. So let's go ahead and do the same thing with the second switch and the breaker. So now all three of these points are connected to the single line diagram being displayed. So if I come over here to this value, if I click the value off, it'll change this one right here that I drug it to. And now it's true. Should be able to go through, follow the same process. So now our outstation is monitoring the electrical devices in our single line diagram. So now we have a way to visually see what's going on our network. Let's now talk about how we can change values. As you just saw, I was going in, I opened the database, I manually changed it just by clicking on the value and changing that. You can also say go down to these analog values, come in here, change those, whatever you want. There's all sorts of ways you can interact with it manually. But sometimes there's just too many points or there are too many devices you're trying to change at once. So there are a few other ways that you can show that off. The first is very simple. It's auto data changes. This is essentially what you're going to use if you just want to do traffic. So you right click on your device that you're interested in. You do simulate auto data changes. And what that's going to do is it's going to look through all the default points that you have inside of your device. And that's going to be for DNP, class 1, 2, and 3, and all events. So there are 202 points inside of this that auto data changes thinks you're going to be likely to want to change. Of course, you can open this up. You can remove all the points. You can remove out single points by dragging it here to this trash can. You can grab points specifically from your device and drag it into the auto data change. So it's completely configurable, but we're just trying to make this as streamlined as possible. You can give it a name, say if it's for a specific test. You can change the interval. I normally do 2 seconds. You can change the percentage of these points. So if you have 200 points being changed and you only want 100 to change per interval, you put that to 50 and you're going to get 50% of those points changing every 2 seconds. So now when I hit OK, you'll see a little hammer has appeared right here on the workspace. And what that allows you to do is you can then interact with it. So if you just want to change the values once, you can right click and do change values once, and you'll see all the values out here have changed that were in those 202 points. Or if you want to start playback at that periodic rate, you could click start auto data changes. And what you'll see is every 2 seconds, the values of everything will change. So that's how you just create kind of a default load on your network, just wanting to toggle points, increase analog values, just kind of generate traffic. You can also be more specific with this. If you want to say, as someone had asked earlier, set up certain states, you can use what is called a CSV simulation file. So you just right click, simulate, CSV simulation file, and then I'll import that similar to how I did the SCD file. I've got one right here. And what that's going to do is it's going to bring in this simulation file, which is CSV file. So if I hit OK now, it's going to bring up the configuration window for this. Essentially, it's going to ask you a few questions. How do you want to describe it in case it's for a specific test? When the simulation has fully gone through every state, do you want it to loop back again at the start? I'll do that. How long do you want to wait? I'll just do 2 seconds. And then when you are doing periodic playback, how often do you want it to change? Again, I'll put that at 2 seconds. Of course, if you just wanted to run through a series of steps and then stop, you would just not put restart playback when complete, and then you would monitor for the specific responses you expect your system to have. So when I hit OK now, we can do a right-click, show data points. And what that's going to do is this is going to show the data points inside of this outstation that this CSV file pertains to. So it's going to be right here in these values right here. So now if I right-click and say apply state, I can select one of the 4 states that I have. So I click state 1, click apply, and we'll see that all of these values have now changed. You can go to state 2, apply. Again, all these states have changed. Similar to the auto data changes, you could then do start playback, and you'll see that they're going to every 2 seconds cycle through each of these states. And then if I configured it properly, it should start back over. So that's how you do playback for CSV. This is how we envision you setting up initial conditions or scenarios for a test. You want to have these 3 things happen and make sure that your system responds properly. The last thing that we're going to be looking at is scripting. And I've showed you that a little bit today, but I want to give you a little more into how it's created. So you right click, Insight, and then add a script. From here, since I don't have the script outside of DTM, though you could write it up outside, I'm just going to name it test. Now, this is a JavaScript fully built into DTM, meaning anything that you can do with JavaScript outside of DTM, you can do in here. This includes conditionals, this includes loops, state machines, anything along those type of lines you're going to be able to do in here, importing files, any of that type of stuff. But we have added a few other functionalities to it to help support your DTM interaction. So for one, you can grab some of your points and drag them specifically over. This will give you a variable that links directly to that. So I can say binary input 1. And now I could go through and say, you know, binary input 1 equals on, right? And then if I run this value will go through and press it. Or you could do, you know, if binary input 1, and then, you know, come down and do a conditional based on that. It's just a script editor. This is how we do a lot of our behavioral testing. This is how we do some of our test manager scripts like I showed you before. This is all just kind of built straight in. And if you need assistance or you're not super strong in scripting, this is absolutely something that we help out with. So I'm not going to save those changes off. So that is how you create your devices, how you display your values, and how you go about changing those values. I think we're going to take a second break here to answer some more questions, and then we'll get back to, I think, the PowerPoint. So Beth?
Yep, okay. Well, we definitely have the questions pouring in. Hopefully you guys are seeing the online answers as well. Let me go ahead and give you some, Matt. First one, can we import the previously existing CID files for many devices here?
Yeah, absolutely. So today I only showed off the SCD file because I wanted to show off the selector and the import substation. The SCL file, when you import, it does not have to be an SCD file. I know I'm using a lot of 3-letter acronyms, but you can do any type of SCL file. That's IIDs, ICDs, CIDs, anything along your 61850 needs, you can import through there.
Okay, next question. How many outstations and master stations can be simulated using DTM?
So that is definitely a good question. We have customers who regularly simulate hundreds of devices on their workspaces, though some customers only do 5, 10, 20. It really depends on what their case is. For an example, my personal laptop can simulate, that's about 7 years old, can simulate about 100 devices with about 70,000 points total when the auto data changes are changing about every second. But of course, this is going to be really dependent on what your use case is. We do have some customers who do up to 1,000 devices. And we're always happy to outline what requirements you need, what type of PC you'll need, RAM, CPU, anything along those type of lines, and give you a good estimate on what DTM's going to need to run certain simulations.
Okay, next one I have, and you might have already covered this in the demo itself. Can I add multiple IP addresses with the same port number? This needs to configure under multiple devices tab manually, or is it automatic? He's asking specifically for DMP, but I don't know if it's, works across all protocols.
Yeah, so it sounds like you're probably getting closer to deployment with what you're working on, and the answer is yes. That's the whole reason we added the add IP address function to DTM. If if you're getting close to deployment or you want to use your realistic IP addresses, you can go ahead and add the entire subnet of IP addresses that you need directly to your machine and all use the same port because you're talking off a different IP address. The only thing you don't want to do is have the same configuration options from top to bottom, IP address, port number, session, any of those type of things. If they're all identical, you're going to have IP conflicts. But if you add a bunch of IP addresses to your machine or you already have them, you can absolutely put them all on port 2000 or 20,000.
Mm-hmm. And we've gotten a couple of questions along these lines, so I'm going to sum it up, I think, a little bit more. Someone's asking, does DTM functionality cover the facilities of protocol test harness? And again, there's been a couple of questions coming in asking about really the differences between DTM and test harness. It sounds like a bunch of you already have test harness. What does DTM do differently?
So test harness is normally considered to be used as a tool that will help you configure, say, your single device. You can run your conformance tests through test harness. There's no conformance test in DTM. DTM is really when you want to simulate multiple devices at the same time, if you want to do behavioral system tests, if you want to do any of the things that we showed in the PowerPoint earlier. It's not normally for a one-to-one test. While you could use DTM to simulate, say, your one DNP master and you have your physical one DNP outstation, it's a little bit overkill, and that's kind of where test harness really shines. So they do similar things, but they definitely have different use cases in the field.
Okay. Does DTM have readily available test scripts for 62150 and Modbus?
So if you're talking about test scripts being the test manager, we have a few examples built into the sample workspaces that you can go and see how we went and set things up. Specifically, we're talking about the gateway one that I showed off very heavily in the previous webinar. And you can absolutely go in there and learn how those test scripts are done and apply the same ideology to DNP or any of the other protocols. And then we have a sample workspace multiple sample workspaces for all the different protocols, where you can go in and see examples of CSV files, of scripting, of controls, of everything that you kind of need to know to get a good start there. And as I've mentioned probably a few times in this webinar, we really love to see how customers want to use our applications and figure out what their use cases are and how we can better design our tool to meet those needs. So we love working with people. So if you need an example of how you could perform X, Y, or Z test, we're absolutely ready to sit down with you and talk to you about it and provide you samples, examples, or potentially the workspace that you might need to get started. So don't let scripting scare you off.
Okay, with that, we've got about 5 minutes left of our scheduled time. So Matt, I'll hand it back over to you. And then once we wrap up, we can certainly go back to questions and answers.
Sure, so I'm just gonna jump back over to the PowerPoint. I think we're just gonna do kind of the summation of what we've talked about so far. Today I've shown you how DTM can simulate your missing hardware and how it can be used to simulate protocol traffic in your network, or even be used to simulate device behavior inside of a network. We've also showed you how your team could be more confident in your test sets. DTM provides you with a safe environment to learn tests. It helps you diagnose problems ahead of time and hopefully reduce time while on site when you are forced to travel. This webinar will be posted to our GoToWebinar page and also our YouTube channel. This way you can share the webinar with others who may not have been able to attend today, or potentially to review information down the line if you decide to pick up DTM or you need a reminder on what we talked about. We also have some documents about DTM, which you can download directly from the GoToWebinar app that we have open right now. And as Beth has mentioned, we're going to stay on air now that after the webinar to continue answering questions or any specific needs that you may have. But if you need to jump off, there's any unanswered questions, things that haven't really been addressed, and you have to go, you have another meeting or something come up, feel free to send any of your questions to sales@trianglemicroworks.com. Even if it's not sales related, we're just trying to group them all in the same place. If it needs to be forwarded on to me or any of the other engineers here, we absolutely want to make sure everyone gets all of their questions answered before we leave today, or at least have some sort of response to your questions if you do have to duck out. And with that, I think we're kind of going to open up just to more questions and see how things kind of continue to trickle in.
Okay. Yeah, so just as Matt said, I would encourage you guys to still continue to ask questions online. Again, they are being answered by the engineers that are monitoring right now. I'm going to start to go through. We've got a little bit of a list here, but as long as they keep coming in, we'll keep answering them. And then Matt, just let me know if you want to throw it over to someone else, one of the other panelists that we've got answering them online.
Right,
so the first one I'll start with here is it possible to capture data packets while doing tests?
Yeah, so we have a built-in protocol analyzer, and what you can do is you can open this protocol analyzer and actually see what values that DTM is sending and receiving. And it's all scope-based, so if you do it out of folder, you're going to see all the protocol traffic going in and out of the devices in that folder. If you do it at the top-level workspace, you're going to see everything that workspace is generating. So that way you can see all of this stuff, you can log that information, you can export it, and have access to all of the protocol traffic that you're seeing during your tests.
Can we directly, oh, I'm sorry, one second. Do you have a template / model scripts for objects such as pumps and valves?
Not yet. We are working on some generic behavioral scripts for some of our protocols. It's not officially out in DTM right now, but we will be posting these out eventually and allowing people to kind of adapt how we've done our kind of behavior in a substation. But again, if there is a specific test or behavior or something, contact us. We can try to get you something maybe either ahead of time or something specific for your test case.
And this one, I believe, is covered in the demo, but just to make sure everyone understands, can we simulate 62050 servers?
Yeah, absolutely. Hundreds of servers, depending on what your use case is. You can have, only servers, only clients. You can have a mixture of the two. I'd say about half of this, I'm sure this question was asked a little early on, but about half of this webinar and the workspaces that I was working on was 62850. It is definitely one of our popular protocols.
Yeah, that was a recent one. That's why I wanted to make sure we kind of hit that message. Can we check interlocks in between substation elements in IEC 61850 that we are normally giving using DCU?
Yeah, so that's why I added the two switches on the side of the breakers. We actually have some interlocking code written into the very first finalized workspace I showed you. So interlocking can absolutely be monitored and tested there as well. It all just comes down to what kind of behavior and scripting you have behind your simulation.
And I've got a question here that I can go ahead and answer. It's actually come up a couple of times, and I've tried to answer online. I've got a bunch of folks asking if there's an evaluation license that you can download for DTM to try it out yourself. And yes, there absolutely is. You can go to our website, www.trianglemicroworks.com, and go under login or go under the DTM product page, and you will be able to download a 21-day eval, so you can start to play with DTM and try it out yourself. If you are working on a VM, please email sales@trianglemicroworks directly, and we can get you a key. The download will work on your PC without any interaction with Triangle, but again, I need to give you a key if you're working on a VM. Okay, so next question. Does DTM support work with virtual port training purposes?
Can you repeat that one more time?
Does DTM support work with virtual ports in training purposes? Not quite sure.
Yeah, let's pass that one over to Dave to see if he has a little more insight on what that means. We definitely have configurable ports, and it's definitely used in training scenarios, but I'm not quite sure what the question's asking directly. Dave, are you on the line with us?
He is there, and I'm attempting to unmute him. There you go.
Yes, I think again, I'm not sure I understand the question either. I mean, certainly with DTM, you can configure any protocol on any address supported by the machine and then any port number. So you can have 100 servers all on the same address with different port numbers, or you can have different addresses in the same port number. It doesn't matter. As Matt pointed out before, as long as those two values aren't the same for any two, you're all set. I don't know what the term virtual port would be. I mean, yeah, I'm assuming it's some variation of that, but I've never heard that term before.
Yeah, so if we didn't address your question or answer it properly, maybe just shoot us an email with more specifics for it. I would assume if it's just kind of a networking term, it's absolutely something that we cover. It's probably something that we've discussed and, like Dave said, use different terminology for. But if that didn't clear up the question, feel free to shoot us an email and we'll look into it and get back to you.
Okay, next question. Can you record behavior answers from a real ID and then save and reproduce them with the DTM simulator?
That is definitely something that we are adding into DTM, where you can monitor the responses of a physical device in the hopes to replay that behavior later. But currently that's not built straight into DTM. So I think that should be on the horizon coming up soon. But
Okay.
you could absolutely script up the behavior, monitor the behavior of the device, figure out what it did, and then script that up inside of DTM and perform that. That can be done through scripting or through CSV playback.
Is it possible to work with real IEDs in the simulator?
Oh yeah, so I should have mentioned this earlier on, but when you simulate a device inside of DTM, the external world has no idea that DTM even exists. It thinks there's an actual device sitting right there on your network. Meaning if you send out a goose signal and you have another physical device inside your testing network that's subscribed to that goose signal, it's going to see that. Any sort of DNP, Modbus, 101, 104 protocol communication that gets sent out of your network adapter is going to go out into your network as if it is an absolute real device. There's no smoke and mirrors going on behind the scenes. As far as the world is concerned, these are real devices. So yes, absolutely. The whole idea is you simulate your whole network and you put real devices in it and you verify that the devices are working. So yes, absolutely.
Okay. Is it possible to simulate triggers or pulses with a duration of milliseconds? Sometimes it's important to know if SCADA detects faults from relays.
Yeah, so we are running on a Windows machine. So that means that we can only get down to the milliseconds level that Windows allows. But that is absolutely something that you could handle, again, within scripting. You could go in, set a value and then say, wait 200 milliseconds and then pull that value back down. And that's how you could generate kind of your pulses. But again, if you start trying to get down into the really, really slivers of these milliseconds, you may have a little bit of difficulty as Windows only gives us so much power.
Does DTM support line animation in a single line diagram?
I would say yes. I'd have to know a little bit more what visuals they're looking at seeing. From the single line diagram I showed off today, I didn't necessarily point it out directly, but red essentially meant hot, it's energized, and green meant not energized. So when I did the breaker failure, you'd see at the very bottom that the transformers were no longer energized. That's one of the type of animations we do. Hopefully, depending on screen size and how well I was zoomed in, you could see the breakers opening and closing. When I did the DNP single line diagram, The whole background color was red and green, just in case you can't see the little lines in there opening and closing. So yes, all sorts of properties are inside of each of those icons, and they can be tied to all sorts of different things, and their behavior can change based on that, and that's all animation.
Okay. Next question, and you kind of touched on the time sync a little bit here already. Can we conduct FAT testing using DTM, and how about time synchronization in DTM testing?
So yeah, if you're gonna do a time sync, what you need to do, I think, and Dave can correct me if I'm wrong here, is to have your whatever machine is simulating your devices sync up to whatever is the controlling time sync out in the network. So if you're sitting in a testing network at, say, a lab somewhere, you just sync up with whatever is in the lab. But if you go out on site or anything like that, you're gonna sync up with whatever master is there as well, and that should automatically cover time sync for you.
Can we write TCL commands in DTM like we used to write in test harness?
So we're doing everything in JavaScript in DTM now. So we aren't doing, I think that's Tickle inside of DTM right now. Just because it was really hot and popular when we released Test Harness, and now JavaScript seems to be what a lot of people are using, and seems really user-friendly. I mean, really user-friendly. It's something you can learn probably the basics of it in an afternoon. There's so many tutorials online and resources you can use. That being said, I think in the past we've had our JavaScript call Tickle functions that we've previously written up, or other programming languages. So I'm not going to say it's impossible, but I would say, again, don't be scared of the scripting. Contact us if you need help, if you need examples, and if you can do Tickle, you can do this.
Is it possible to do relay testing remotely through SCADA with DTM?
Yeah, so it depends on, well, yes, it depends on where DTM is installed. You could have DTM installed on a desktop inside of a test lab, and you could absolutely remote desktop into that desktop and run DTM as if you're sitting there, and be hooked up to the switches, the IEDs, anything in your lab, and run your tests, export them, and get them back to you any way you need to. So yeah, that's definitely something that's really powerful, especially in an environment we are now where some people aren't able to get into work, whether they're quarantined or at home or advised not to leave. Install DTM up on your machines at work and remote into it, and you're good to go.
Okay, I've got like a little bit of a two-part question here specific to 61850. Does the SCD import require any cleansing before import? For example, removing private fields. And the second part to that is, does the 61850 simulation properly simulate the server? Does it simulate multiple report control box and changes?
So let me answer the second part, because that's the easiest part to do first. Yes, if you bring in a 61850 server and it's got multiple report control blocks, it's got goose messages, it's got any of this type of stuff, once you have all the adapters configured and the device simulated, it's going to behave like you would expect it to if it was in physical hardware. That means sending goose messages out whenever those values change, receiving controls and commands that will respond properly to those. If values change, it's automatically going to push out the reports. So it's going to behave just like a 61850 server should. And as for cleansing your files, we try our best to pull in any sort of SCD file or SEL file that we can. If it is, incomplete and is got some missing fields, or it's not up to a certain standard, we may not be able to pull it in. That's when you would use something like Navigator, another tool we have. Bring in your file, verify your configuration file, find any errors or major warnings that we have in there, fix that, and then we should be able to import it. But yeah, we have customers that are 61850 experts and give us the most beautiful files, and we have people who are really just starting out with 61850 and they're still trying to learn the ropes, and we can help both of them.
Okay. Is it possible to simulate analog values? Meaning, can we show power flow on the developed single lines and how the power flow may change during a breaker failure event or load shed event?
Yeah, so we have a few workspaces like that when we've worked directly with customers that show not just the breaker positions, but like the voltages at each line, where it's getting its voltages from. There are several examples of things that we've done with that. For this example, for the webinar, I was trying to keep it clean so you could see exactly what was going on as I built these things up, but don't think it's just binaries. Anything that you have inside of a simulated device, you can put onto a display, onto a single line diagram. You can write up scripts to monitor power flow, where the power is coming from, when it fluctuates, if breakers opens, anything along that type of line with voltages and currents and things like that.
Okay, I've had a couple of questions come in along these lines, so I'm gonna start with the first one, but it really segues into a little bit about our gateway, Matt. So do you have any products which translate into 6150 MMS client to OPC? And does DTM have an OPC server feature?
So the first for does DTM have an OPC server? The answer to that is no, but that is something that we have been discussing and something that we're definitely highly considering. I think it will be a few releases from now, probably. And then to answer the first part of that question, so I mentioned a few times throughout the webinar, just very briefly, we have an application called SCADA Data Gateway. That is our protocol mapping. It's a translator, a data concentrator. These are deployed into substations, right? So this is not a test tool. This is an actual deployable application. Granted, you could use it as a test tool if that's what you needed, just for something in your lab, but it is robust enough to be put into a substation. And it has built-in OPC, UA, DA, A&E. It has client and server capabilities. So it has all of that stuff built into it. And so that's how we would recommend doing OPC inside of Gateway. And again, because we already have all of this code backing up and supporting in Gateway, we're hoping the transition to put OPC inside DTM will go smoothly.
Does DTM support custom-made complex symbols like a base symbol that can be replicated?
So we have a ton of symbols and icons that you can put on these displays, but we do have a section for import. It's like JPEG or icon or import something, and you can go out and select a icon or a symbol or something that you need and import that directly into your workspace and then reuse that. So we do have this generic import section. I think you can also import sounds and videos or anything along those lines as well. So yes.
Okay. If there are communication problems between IEDs with the master, is it possible to determine the error?
Yeah, so one section I didn't really highlight in this webinar at the very bottom is an output, and you can configure what shows up in this output, but any sort of communication errors is going to be popped out down there. So if you connect and then it's immediately rejected because you lost, say, someone ripped an Ethernet cable out of your computer, or you lost wireless or whatever you're doing, you'll see the failure right there down in the output. And in case things are going too fast, there's too much going on at once, you can't keep up with the output, there's also a error log button that you can click and it will bring up all sorts of errors, and then another tab is all the warnings. So you can go back and actually watch what happened when the error happened and figure out, oh, the very first thing that happened before all these error logs is I lost, say, my Ethernet cable or something, and that had a trickling effect of all my devices disconnecting or whatnot. So there are two ways that you can monitor that directly.
Is DTM able to synchronize with NTP protocol during FAT?
NTP. I'm assuming that's a time. Let's go back to Dave on this one. Is that it's just time sync?
Yeah, network time protocol is NTP.
Yeah,
Windows, sure. It's not DTM. Windows supports NTP, SMTP, PTP, basically most of the major time protocols. So you can actually configure your window box to sync to those time servers. If you have typically people will have a local time server running one of those protocols as their standard, and you simply sync the Windows box to that time protocol. And yes, it supports network time protocol, the simple network time protocol, or PTP.
How easy is it to move licensing from one machine to another temporarily or permanently?
So we didn't touch on licensing too much during the webinar, so I can go ahead and explain that a little bit. When you purchase DTM, there's a few configurable things for your license. First is how many devices are you going to simulate? And then the second major one is which protocols you're interested in. Another configuration option, which is going to touch more directly onto your question, is what type of license it is. So if you've got a seat license, that's specifically made for a desktop or a laptop or a VM, and it's for that specific machine. There's probably a way you can transfer it from one machine to another doing that, but if you're going to be doing it frequently, I'd recommend one of the other two options. And the other two options is you can have a network license, which just means you have a network license and say you have 2 users on it. The first 2 people who come in and decide they're going to work on DTM that day can start up DTM on their local machine. They're connected to the network. They get a license. They finish their test. They close down DTM. The license gets relinquished back up to the network, and then another person can come in and get that as well. And you can have up to 2 users at once if you had 2 licenses, or 1 or 5, whatever you want. And then the other option is you could purchase a licensed dongle, which is like a little USB stick. I'm sure you have seen them before. And the license is strictly on that. So whatever machine that's plugged into is what's going to have that license. We do caution with dongles, though. There have been times where you lose the dongle, you lose the license. We try to help out with that as much as we can, but it can be scary to have them lost. So make sure you are very careful with your licensing, regardless of the way you decide to pick it up.
Okay. How do you check responsiveness and latency?
So we did that today using the JavaScript, right? So the JavaScript, you can monitor the initial time that your initial conditions were set up. And then after you get through the entire fleet of tests, whatever you're checking, you can then determine an end state and find the difference there. That's how I was getting the 100 milliseconds, 150 milliseconds I was showing with the gateway mapping tool. That's how I was getting the 2 seconds with the recloser tests. So you can definitely do that via scripting super easily. And there's also in the output at the bottom timestamps associated with different actions that the system can perform. So you could obviously look at those timestamps as well. And then, of course, if you're inside your protocol, your values and stuff are going to have timestamps as well. So you should be able to go back and look at those as well as the protocol analyzer. So all over the place. There's multiple ways to do it.
Can you use DTM as an actual SCADA program, or does it work with existing SCADA software already used in the network?
The answer is yes. It's not something we specifically designed DTM to be used for, but absolutely it could be. You could create an insight display with all the values that you're most interested in, organize them as you need. You could have devices that connect up to different physical devices out in your network. But know that DTM was designed as a testing simulation tool, and that you might be able to do some things from DTM that other HMI or SCADA systems might frown upon.
Okay. Can DTM be used to set up a real-world substation auto test? What hardware, software in general would be needed?
I think this question is asking, can you take DTM into a substation and run automated tests? And I would recommend, especially if you're doing 61850, to look more into our Test Suite Pro application, because that's more about diagnosing and monitoring what's happening in a real substation. It's got a lot of extra features and tools built into it to really help show you what is happening. Again, DTM is more of a simulation tool, and it allows you to do some things that you may not want to do inside of a substation. For example, if you're in a physical substation and you have a Goose server, you have a 6150 server running, and you accidentally flip a bit and tell it to send a goose message out to open a breaker, like I said, the network doesn't know that's simulated unless you set the test or sim bit or things like that. And you could actually have, breakers open or responses into your physical system that you didn't really expect. So again, DTM is kind of a test tool, but it could be used as that. Just be very careful.
Is it a 70,000 database for all the 200 devices, or one device supports 70,000 points?
I think you're talking about when I was talking about my specific load test I did on my laptop. Again, my laptop's 7 years old. It's a good laptop. It's got a 2.4 gigahertz processor. It's got 16 gigs of RAM. It's a great computer. But when I was referring to the 70,000 points, I think that was across all 100 of the devices. So I think they had 7,000 points that I was changing data with every second or something along those lines. But hopefully, as you saw in the webinar, we've had some gigantic devices with thousands of points, hundreds of thousands of points inside of one device. But we've also had some workspaces that we've simulated where they had only, 100 points in it. So it's all absolutely configurable, and you can set that up however you need. And of course, if you distribute the load of your workspace across multiple computers, then you're gonna face a lot less load restrictions than if you try to simulate a massive amount of points and data devices on one computer.
Okay. Can we log all the events for 200 devices if we run for longer duration, like 3 days?
So yes, logging is definitely built into DTM. The problem runs about when you start running into resource issues. So it depends on, all sorts of things. I mean, could you log every single point change every 2 milliseconds for an hour? Probably not. I mean, that could be a lot if you're changing data super fast like that. If you are doing more of a, every 30 minutes we're doing a thing, we need to monitor it and we want DTM to run, well, absolutely, you could do that for 3 days. So it really depends on what your computer can handle and what type of test you're running. So I will say yes, tentatively.
Okay, and this question's come up a couple of times, asking about some different protocols. What about Profibus DP simulation? Is that offered?
So the protocols I talked about today are what's built into DTM. We're definitely open to looking into new protocols going forward and figuring out what the industry is using and what would help the majority of our customers. But currently it's 101, 104, DMP3, Modbus, TASI2, and 61850.
Okay. Well, I think we've gotten through all the questions. If there are no other questions, I think we can go ahead and wrap it up. I want to thank everyone for joining us and hanging on even a little bit longer. We were happy to get so many questions and be able to answer them as well. There will be a recording sent out in a follow-up, so you can review this again. We will also send out some additional information on DTM. Just if you, again, to recap, you can definitely download an evaluation license at DTM from our website. And if you have any other specific questions, please email sales@trianglemicroworks.com. Well, thank you again for joining us, and we look forward to seeing you at our next webinar.
Thanks for coming by, guys.